Let's take a look here. So here, there's your variable. Right? There's no other variables anywhere, so it's the numbers that are kind of like not together yet. So of course, what are you going to do to get your x by itself? Subtract 7. I want to kill that plus 7, so I'm going to minus 7. So I get x equals negative 10. I love it. And to check it, negative 10 plus 7 equals negative 3. Check. Cool. I like it. B is pretty much the same thing, except I got a negative 5 added to x. So how do I kill the negative 5? Got to add 5 so that I get 0. So that just goes away. X equals 12. And then to check it, negative 5 plus 12 is 7. Check. Yay. Let's see, and then C. What's the operation right now? Multiplication. I got that negative 12 I don't want. I'm not going to add 12 because there's no subtraction happening. Does that make sense? Yeah, I got to divide because that's the opposite of what's happening. I get x equals negative 4. To check it, what's negative 12 times 4? Negative 4, sorry? Positive 48. The two negatives cancel. I like it. Real quick, let me see. Here's 0. When I multiply something by negative 1, I want you to really start to look at it. This is going to help out a ton when we get to those weird-ass complex numbers. So right now, when I multiply by what's 2 times negative 1? You see how it turned all the way over here? So this is times negative 1. So of course, if I multiply by negative 1 again, it comes back to 2, right? So if I have negative multiplied, it's going to come out to be positive because it comes right back to where it was. It's like, turn. Now turn again. I'm back to where I was. The two negatives cancel each other. Is that cool? When I add negatives, when I have like negative 2 minus 2, I'm combining negatives. They can't cancel because now it's a different idea. It's not multiplying. It's not that idea. It's now just a consolidating debt. Right? Negative 2, now I'm 4 in the hole. Yeah. It's cool. Maybe. So I know it's frustrating as a student when you're like, we said yesterday 2 negatives cancel. Today this guy's freaking kidding me. It's because multiplying. When you multiply negatives, they cancel. When you combine negatives, they just get more negative. Okay, alright. So what about D? It's the opposite of C, basically. Right? We've seen this one already a few times. What do you want to get rid of? 7. So the x can be by itself. So I'm going to do what with 7? Multiply by 7. This is 21. And then to check it, what's 21 divided by 7? 3. Check. Yay. Now we start to get a little more interesting. Multiple things happening. Get out of there. So just remind yourself, you almost always divide last. So if you start to divide by 4 and you see there's more shit to do, go, no, this can't be right. I should not be dividing first, normally, right? I will show you a problem where you could divide first and it would make sense. I'll show you because I keep saying that you almost always. So what do I almost always do first then, really? If there's no distribution to do, is I move the numbers. So I want to get rid of him. So what do? Add 1. So I get 4x equals 12. And now you can divide by 4. Because you consolidated all your numbers so you can just attack that one thing with dividing by 4. It's another way to look at why I don't divide first. Oh, now, I don't know if you guys want to see this. I could show you what it would look like if you divided by 4 first. Right, here's what it would look like. If you divide by 4, you can't pick and choose. You divide by 4. You must divide everything by 4. You can't say, I don't want to divide it by, yeah, too bad. If you choose to do it, you got to do it. So that kills a 4, great, but then what do you got here? This isn't that terrible, right? What would you do next? What's in the wrong place? 1/4. It's in the wrong place. So I would do what? Careful. Add it. And that's not too bad, right? What's 11/4 plus 1/4? 12/4, which is 3. So I'm not telling you don't divide first because it makes it not work. It's just because it makes it harder than it should. It'll still work. Should. Because you got to divide by 4 eventually, just don't do it first. Unless you want to. It's totally legal. You know so far? You guys alright? Some of you guys look upset. You're like...
That last one.
This one?
No, the last one.
Wait, oh, the last one on the... Okay. We're getting there. Alright. Oh, shit. We need the bonus up there. Okay. Do this in a different color. Is green gonna work? Let's see. Where am I at? EF. So it's better if you get the one that aren't low odor. The high odor things are not gonna so again, it's all about, if you can look at it, the goal of equations is get x by itself. If you can look at it this way, what's in the wrong place, and you can identify it, you know what to do first. What's in the 6 is in the wrong, all the x's are together. There's no other x's running around. It's the freaking numbers that I got to corral, right? So I get to get the 6 out of there. How do I kill a 6? Yeah, the 6 is not multiplying by something, so I'm not going to divide by 6. I'm going to subtract 6, because 6 minus 6 is 0. I always get somebody that does this, and then I'm like, that's 12, right? So if you're trying to kill something, make sure it actually dies. Just take a second. Don't just go, I did the opposite of subtract, so it must be dead. No, it's not dead. Look at it. It's 12. You doubled it. You made it stronger. You want to kill it. And then finally, what do I do last? Yeah, the -5 I don't want. It's multiplying, so I divide by it. And what's 5 divided by -5? Good. There's no other negative to kill that negative, so it's still negative. Lock it. Okay. Alright, this board is a little too full. Let me come back here. Everybody got what they want from that board there? Probably more than you wanted. G is the first one where we got choices to really make, because everything's in the wrong place. Right? The x's are in the wrong places, and the numbers are just not together. Just got to get them together. So beautiful. So it doesn't really matter which way you go. I sort of tend to keep my x's positive, so I would subtract 3x, but it really doesn't matter. Right, so I don't know what you guys did.
Subtract 3x.
Alright, I'm just going to do it. So this is what... Just watch. If you didn't do this, let's see if we end up in the same place. This is unbelievably important, what I'm doing right now. And some of you guys don't realize how important it is, what I'm doing right now. That's gone. That is still here. The equal sign is there. 8x minus 3x is 5x. The minus 11 is still there. If you don't do it, if you're just like writing them all over and then bringing them back together, things are not going to go where they're supposed to. Yeah. No. What's 3x doing to this side? I'm not getting rid of the 3. I'm getting rid of the 3x. if I divided by 3, again, so here's what it would look like to divide by 3. You would kill the 3 if you divided by 3, but then you made a fraction there, you made a fraction there, you made a fraction there. I don't want to work with that. Obviously I could, because I'm damn good at math. But I would not do that. I wouldn't want to. Yes?
What's the difference between, like, when you add something to one side and to the other, but when you divide it to everything?
Oh, I love it. I love it. All right. So let me write this again. So whatever you do to one side, you must do to the other side. So if I want to divide this side by 3, I must divide this side by 3. But then you see how it's this over this, this over this, this over this, this over this. So you just go ahead and put it under each, just as a quick way to do it. So watch this. If I add and subtract, and I subtract 4 from this side, isn't it just like terms then? So that's why it looks like it only affects one thing, but it is the whole side having 4 subtracted. It's just a like terms thing then. That's a good question though, I love it, yes?
If I subtracted the 4 first and got 3x by itself on one side, then
You're fine. Yeah, no watch, let me catch up to you. Watch where it comes out the same, watch. So some of you guys subtracted 8x eventually, right? Right? If you did that, you must have subtracted 8x. Now here, I'm going to add 11. So look what I get. I get positive 15 and positive 5x. You got negative 15 and negative 5x, right? But when you divide, what happens to your negatives? You cancel and you get positive like I would, right? But do you see why I do that? So dealing with fractions is a place where humans can make mistakes. And I just say it that way because I'm not saying I'm not human, but it's just a human thing to do. Right? And negatives are where humans can make mistakes with math. So if I have a choice, I'm not going to let fractions show up too early, and I'm not going to let negatives show up if I have a choice. That's why I would always subtract a smaller x so that I don't get a negative. Do you have to? No. You guys did it. You're fine, right? Can you eventually get x is 3?
Yes.
Because the negatives cancel? But it would have been like slightly easier if you didn't have to worry about the negatives at all, and you have that option. Because it doesn't matter which way you go, as long as you get the x's on one side, the numbers on the other. Who cares which side they are? Yes?
Does it matter if it's negative 3 or?
It would matter. Yeah, totally. So if looking at the other way to do this. So just to show you, if you subtract 8x, or let me see, do like you said, subtract 4 first, right? Okay. So you get 3x equals 8x minus 15. Is that cool? Subtract 8x. What's 3 minus 8? Negative 5. And over here you got negative 15. So when you divide by negative 5, the negatives should cancel, so you should get 3 still. Because the two negatives cancel. So it doesn't matter which way you go, it's going to come out at the end. So. Okay. No, I'm sorry, it's just messy. Let's see, where am I at? G. H, okay. Let's do bonuses and not wait. Alright, so H. Now obviously we're pretty good at knowing what to do first here. Yeah, everybody kind of was in agreement that's an automatic thing. Because then that frees up the parts of this to move around. It's all about moving shit around. You can't move it around if it's stuck inside here. What's the next thing I do? Yes? Yeah, so I would subtract x. And subtract, let me see if I can do two things at once. So we get x equals 2, done. The negative 2, yeah. watch. So if I had -2 in front of something, I'm going to distribute -2, right? Just because I put something there doesn't change the fact that is a -2. In fact, do you guys remember 5 minus 2? What's another way to write that? 5 plus a -2. So see how I can write that as this? What am I distributing? -2. Yeah, so the minus sign is a negative. Plus sign is a positive. And then finally, I was the freaky one, right? That's the one that angered somebody. What time is it? Not. Alright, so there's only one side here that's got stuff I can do, so what do you do over here? So this is kind of like your question. See, that's, who asked that? That's what's going on. Do you see that? The -2 distributes, just because there's an 11 there doesn't change what I'm doing, right? So I still distribute -2. So you get 11 minus 2x minus 6. Is that cool?
Oh, it's just a question about the last problem, but I could ask that.
What's up?
She got 3, I got 2, and when I plug 2 back in, it doesn't equal.
Yeah, but when I put 3
You did, sorry. Just to be really blunt. You put a 3 in there, 3 plus 1 is 4 times 2 is 8. Minus 1 is 7, but 3 plus 3 is not 7. Plug a 2 in, 2 plus 1 is 3 times 2 is 6. Minus 1 is 5, and 3 plus 2 is 5. So that would work, both sides would be equal. So 2 works, nothing else can.
Could you just do that again? 2?
Yeah, so 2 times 2 plus 1, right? Put a 2 in for x.
Right,
Minus 1 is supposed to be 3 plus 2.
right.
What's 2 plus 1?
3.
Times 2.
Okay, I distributed first. Did I not do that?
No, you can't. You can, but 2 times 2 is 4.
4 plus
2
1.
times 1 is 2.
Right.
Minus
okay.
1. 4 plus 2, 6 minus 1 is still 5.
Yeah,
Yeah, yeah.
was off, sorry.
So don't distribute unless you have to.
Okay.
I only distribute if I can't do what's in the parentheses.
Yeah, that's
So what do I do next here? Yeah, so I got 5. See what I do there with the like terms? Just use different underlinings instead of moving shit around or whatever. -2x plus x. Yeah. owe 2 and I give them 1, I still owe them an x. So it's still negative x. This might have freaked people out. Now look at it, what it says. What is 5 minus x not equal to 5 minus x? Is that ever not true? Is there a number you subtract from 5? A number you subtract from 5 and it's not the same as if you subtract that number from 5. What the shit? 5 minus x equals 5 minus x. It doesn't give a shit what x is, and that's why x disappears. Because it doesn't matter what x is, it's true. No, not undefined.
True.
No, not true either. That statement is true. Therefore, what is the solution or the solutions? All real numbers. Does it matter what you make x? Look, look, look. Does it matter what you make x? No, it canceled. X doesn't do shit to this equation. 5 is 5. Therefore, this equals this always. Watch. When is 2 times x plus 1? When does that equal 2x plus 2? Does it depend on what x is? What did I do? I distributed, right? Does it matter what x is? This would always be, so the answer to this would be all real numbers. Because if you solve it, you subtract 2x, you get 2 equals 2. When is that true? Always. When is this true? Always. What's the answer? All numbers. All real numbers. Any number. You can try. How do you check it? Pick a number. You pick your favorite number. Plug it in. It'll work. Pick another number. Plug it in. It'll work. Every number you can try to plug in there will work. I like it. Okay. Let's see, real quick. I'm trying to leave enough time for this field trip.
We'll all just agree that we did.
What's up?
We'll all just agree we did the fellowship.
No. No, come on. What's wrong with you guys? So times 4. Look. What am I doing right there? Why am I doing that?
You like it?
Make all the denominator the same. You can do it, Jeff. Now I can multiply both sides by 12. They all die. So then add 4, I'm done. Add 4. Is that right? Yes. Add 4, you get 19. Is that right? Should be 18, right?
18.
I did this too fast. 3, 4. Oh, I lost by +1 right there. Duh. Sorry. Trying to do this faster. So you get x minus 3 equals 15. You get x equals 18. I like it. That's bonus. That's beyond where we are. So if you don't understand that word shit, don't worry about it right now.
I just multiplied everything by 12.
I love
works
it.
Too, but
That's
it's
beautiful.
too complicated, or no?
No, I like to do this because when we get variables on the bottom, it makes it a lot easier to make them all LCD. So here, 2 and 5 means what would the LCD number be? 10. So everybody's got to have a 10 and everybody's got to have an x. So he needs a 2 and an x. He needs a 5. So much easier to think like that. And then I got 20 over 10x minus 8x over 10x equals, what is that, 85 over 10x? Then I can multiply by 10x on both sides. It cancels everywhere. Bam, 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 bam. If you make all the bottoms the same, you multiply by that bottom, no more fractions. Then you get 20 minus 8x equals 85. Subtract 20. Negative 8x equals 65. Divided by negative 8, you get negative 60. I know I did that fast. I don't care, because that's just for the people that tried it, and it's way beyond where we are. So don't feel bad at all about these two. Let's pack your stuff up, because I can't lock the door. I'm going to make this as quick as I can, a little field trip. Do this for me, guys. Do this for me. Start to walk out the door in this direction, but go really slow. Wait till I get in front of you, so you know where the shit you're going. Okay?
So we're going down to the little boxes thing, right?
I have to use the restroom really
I'm gonna